Today we're going to go over lesson 8.1 over the Pythagorean theorem. So let's go ahead and begin by filling in some blanks. The Pythagorean theorem says a triangle is a right triangle if and only if the hypotenuse of the triangle is equal to the sum, which means you're adding them together, of the square of the legs. Okay, so let's look at the picture. The two sides here that come together to make the right angle, those are called your legs. Make sure you know that. Now the longest side here, opposite the right angles, you find the right angle, and it's always directly across. That is your hypotenuse. It's always the longest side. You probably know this better as a squared plus b squared equals c squared. Now we're going to use that in just a moment, so we're going to come back. Next, we're going to do the obtuse versus acute theorem. So if the square of the lengths of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So what we're trying to do here is, if I only give you side lengths and I don't give you a picture, can you tell me whether or not if it's right, acute, or obtuse? Now we know if it's right because we already did that. That's the Pythagorean. The two legs, when you square them, will equal the hypotenuse squared. So now we have this rule. So it's kind of like the Pythagorean. You're going to take the biggest side. It's going to always go over here by itself. And you take the two smaller sides and you square them and you add them together. So if the biggest side is bigger than the legs, notice that's the greater than sign, then that means it's an obtuse triangle. But when you do it, if the biggest side is smaller than the two legs added together and squared, then it is acute. So again, we're going to practice this. And I know my answers are written in, but hopefully, you can get something out of this and understand the process. Now, we're going to first start very basic. We're going to do the Pythagorean. Can you just solve for a side that's missing? Now, you do have to look at it and say, what side is this? This is your hypotenuse, and you know this because it's directly across from your right angle. So that's the side that stands alone. So notice my x squared's over here by itself, and then these two side lengths here, those are called your legs, they are together. So we're going to square everything. So 4 squared 16, 8 squared 64, add those together to get 80. Now, I just bring down the x squared, but how do you get rid of that square? So if you guys remember, you're going to square root it. So if you square root one side, you square root the other side. So my answer is the square root of 80. Now, as usual, look at the directions way up here. This answer should be in the simplest radical form, which means you're going to simplify it. Now, we did this the last chapter by hand. So guys, look way over here where the purple is. We did this. You made the factor tree. You learned how to simplify it. Now, if you have a yellow calculator, you can do it on the yellow calculator, and it's much easier. But if you're taking your SAT, if you're taking I-STEP, this may be on a portion where you don't get a calculator. So it's an important thing to know. But let's stay with the skill of the day. Can you do Pythagorean? Okay, my answer is 4 square root of 5. Okay. Next up, I find my hypotenuse because it stands alone. There's my arrow. I know my hypotenuse is the 10. Notice the 10 stands alone and I square it. The two other sides are my legs. I put those together and I square them individually. So 6 squared is 36. I bring down the x squared. I square the 10 to get 100. So let's take over the 36, and I get 64. And then I have to square root both sides. Okay, so the square root of 64 is going to be 8. Now, if your answer is more than 10, right here, you know that's a problem because 10 has to be the biggest number. So make sure that your answer makes sense. And this answer does. Okay, so I'm finding the missing side. Again, I start by finding that hypotenuse. Here's the right angle straight across. All right, this one's a little bit more complicated, guys. We have 3 root 5. So I'm using parentheses. If you notice, 3 root 5 goes inside the parenthesis. And then my 2 legs are unknown x and 3. So they go over here. So when you type this into the calculator, you have to use parentheses. Otherwise, you're going to get the wrong answer. And this happens every year, and people don't want to use the parentheses, and then they miss the problem. So, I mean, you can try it. If you type this in 3 root 5 squared, what it does, it only squares the 5, but you want it to also square the 3. So technically, this 3 is square, or the 2 is squaring the 3, and the 2 is squaring the root. So you have to use brackets or parentheses or something. So be careful. This is a place where people goof up. If your calculator says 15, it is wrong because you forgot the parentheses. Okay. Anyhow, let's move on. 3 squared is 9. Let's move the 9 over. Get 36. How do you get rid of x squared? Well, we all know that you square root it. The square root of 36 is 6. So we are finished. Okay, where's the hypotenuse? It's across from the right angle. So my hypotenuse is x. My 2 sides are 7 and 7. Those are my legs. We know those legs stay together here. The hypotenuse stays by itself over here. Now, if you notice, I kind of flipped it. I put the hypotenuse on the right instead of on the left. And guys, it makes no difference. So, I mean, if that bothers you, we can put the hypotenuse again on the left side. It makes no difference. So 7 squared and 7 squared is 49 and 49. Add those together and get 98. I square root both sides. And it doesn't look like I put the answer here. Okay, so, and I don't have a yellow calculator on me, so I'm going to have to do some work. So I need a number that goes into 98. Well, it ends in an even number. So I know 2 goes into it. So that's 2 and 49. And that's 7 and 7. So this is 7 root 2. So hopefully this is what your calculator is telling you. Okay, so now we're going to test it. Is it acute, right, or obtuse? So, guys, if you notice, these are not in numeric order. Pick the biggest number. That's going to potentially be the hypotenuse. So it goes over here by itself. Take the 2 smaller numbers. It goes over here by itself. Now you're going to square all the numbers individually. So 10 squared is 100. 7 squared is 49. 9 squared is 81. So 49 and 81 is 130. Now they're not equal. If they were equal, you would say it's a right triangle. But the legs are bigger. So think about this. You have this triangle and the hypotenuse is smaller. Okay? So if the hypotenuse is smaller, like this right here is typically your hypotenuse. Or that's the angle across from the hypotenuse. It's small. So if this side's small, that means this angle is also small. So that is acute. That's how I think of it. Now, if it was flipped the other way and my hypotenuse was big, that means the angle across from it was really big, which means it is obtuse. Okay, hopefully we'll have one of those in a second. Okay. Now, when you look at the three numbers here, I know you can see my answer. Sorry. When you see these three numbers, a lot of kids don't know which one's the largest because you really don't know the decimal form of 3 root 2. So if you have a calculator, and it could be just a regular calculator, I'm just going to type in 3 square root of 2 and push enter. Now I get 4.2, and look, I already wrote it here, 4.2. So I know it's the biggest. If you're using a yellow calculator and you type in 3 root 2, it probably just says 3 root 2 again. So you need to push the button above enter, the little arrows, and it will convert it to a decimal. Okay, so I know 3 root 2 is the largest. So I square it. Remember, this is the tricky thing when you type it into your calculator. You want the square to go to the 3 and to the root 2. So use your parentheses. The 3 and the 5, those are the legs. You square them and add them together. Now, guys, if you did not use your parentheses, you probably got, let's see, 6 here. 6 would obviously be wrong. It is 18. 3 squared and 4 squared is 25. Now, is your hypotenuse bigger? No, it is smaller. So small means small angle, and small angles are acute. Now, if you look at the directions, there's also one right here that says acute, right, obtuse, or not possible. Okay, so let's talk about why this isn't possible. This is old stuff from first semester, and I really didn't talk about it yet because I knew this question was coming up. What the rule is to form a triangle, the two shorter sides, before you even square it, just the 8 and the 10, when you add it together, it has to be more than the third side. It has to be more than the biggest side. So when I add 8 and 10 together, obviously that's not more than 20, so it doesn't work. This doesn't form a triangle. So if you try to draw this out, like this side could be 20, this side could be 10, and this side is 8. They don't meet. It doesn't form a triangle. Now, if you try one of these over here, it works. And feel free to try any of them, like 7 and 9. That is greater than 10. It works. Okay, let's try this one. Pick the biggest side. The biggest side obviously is 32. Let's square it and get 1024. Pick the other two sides, square and add it together, and I get 580. Now, the hypotenuse is bigger, right? So that means opposite the hypotenuse is a bigger angle. So that means it has to be obtuse when we're finished. Okay, so again, on this one, if you don't know what 10 root 2 is, type it into your calculator. If it's the yellow one, push the little button above enter. Hopefully you get 14.1. So we know that's the biggest side. So it's my hypotenuse side. I'm going to put it over here by itself. The two legs I put over here by itself and square them. Now, again, this is the tricky one. So make sure you're putting the parentheses in your calculator, guys, because otherwise you're going to get the answer of 20, not 200, which would cause your answer to be wrong. Okay, so I get 200 and 200. So if it is equal on both sides, this is just the Pythagorean theorem. This means it is a right triangle. All right, so moving on. Now, these really aren't difficult. You just have to draw the picture out. So you have a square. So everyone knows what a square looks like. So just draw a square. You know, all the sides are equal. So that means they're all 9. So just go ahead and draw the 9s in. What is the length of the diagonal? And some people are probably going, I have no clue. Well, guys, this is really just two triangles. So this is my x, this is 9, and this is 9. So is X my leg or is it my hypotenuse? And hopefully you're saying, oh, it's across from the 90, so that is my hypotenuse. Now I know you can see my answer. Let's figure out how I get the answer. So the hypotenuse is by itself, 9 squared and 9 squared, which is 81 and 81. So that is 162. Okay, so again, I don't have my fancy calculator with me. That's 2 times 81, 9 and 9. So hopefully you're getting the answer of 9 root 2. And look, ta-da, that's the right answer. And you never put your answer as a decimal when you're square rooting. You always leave it with the square root within the answer. Next, television sizes are measured the length by the diagonal. So guys, if you don't know this, when you go to buy a TV and they say it's a 48-inch TV, they're not saying across. They're saying diagonally it's a 48-inch TV. So I drew my rectangle. I know it's 48 inches, diagonally. And I also know it is, right here, it says 42 inches tall. So you're trying to figure out how wide it is. So if you look at the part I just highlighted, it's a big yellow triangle. And hopefully that TV has a right angle in the corner. Across from it is your hypotenuse. So my hypotenuse is 48. So I'm going to square it, square the other two sides, and I'm just going to solve. Now, this one's a little different because it says in the directions, if you look, it says to the nearest inch. So when I first did it, I just simplified it like normal. But that's not correct because that's not to the nearest inch. So you need to convert that to a decimal, which if you're using the yellow calculator, you can push the button above enter again. That's your button that usually converts everything for you. And I get 23 inches. Okay, a Pythagorean triple. So as you can see, there are parts I marked out, and you can go ahead and do that. Pythagorean triple is just a set of 3 numbers that satisfy the Pythagorean theorem. And they're 3 whole numbers. And so in case you don't know what a whole number is, they're always positive. There's no decimals. So we're talking like 1, 2, 3, and on up. No negatives. So a Pythagorean triple are just 3 numbers that always work for the Pythagorean theorem. So for instance, 3, 4, 5. If you plug it in, the biggest number, of course, is your hypotenuse, and the smaller numbers are your legs, then you can see they're equal. Now, it says, show that these are Pythagorean triples and give an example of a multiple. Okay, so I'm just showing that this works. So my biggest side is my hypotenuse, the smaller sides are the legs. I work it out and I show that 169 equals 169. Pretty easy. And let's just cross off C. Now here's the hard part. We're going to find the third number in a Pythagorean triple. So I don't want to scoot this up yet, but we can kind of talk about it down here. So when there are 3 numbers, if I provide 2, do you know if the missing number is the biggest side or the smallest side? And you don't know, do you? So we potentially have to try this 2 ways, and it's a 50-50 chance. There's really no way of knowing until you try it. So 12 might be the biggest side. It might be. Or X, the side we don't know, might be the biggest side. So when I tried this, I just randomly picked a side. I said, okay, X is the biggest side, I hope. And so then I picked the 2 other sides as my legs. You know it works if it works out to a whole number. And it did. So I know the third number has to be a 15. Now, if you look at part B, I was hoping that pattern would work again, because when I see the 20 and the 52, I'm like, okay, I need to find the third number. I hope that third number is bigger than 52. So I'm going to put it way over here and hope that it's bigger than 52. But if you notice, when I worked this out, did I end up with a whole number? And I didn't. So I knew immediately it was wrong. And so there's only one other choice. That means the 52 has to be the biggest number. So I put the biggest number there. And so that means X is one of the legs. So it goes over on the right side. Okay, so let's square the 52, square the 20 and the X, and solve. And when I solve it, I get 48. It's a nice whole number, so it works. So the last one here, again, you have to guess, is X the biggest number? And when I did this one, I thought that 293 was pretty large, so I was hoping it was the largest number. And as you can see, it was. So X and the other number 285 were the legs. I square it, I solve, and I get 68. Okay, so this list goes on forever. Down at the bottom, down here, these are more examples of Pythagorean triples. It goes on forever, so there's not just a limited number of them. So guys, that's it. That's all lesson 1. Let me know if you have questions.